Oftentimes, the most important thing to get right about your render output is your output file itself. The settings for this can be found in the Output category in your Output Properties tab. This is the tab labeled with a printer icon. Here you can immediately see a line where you specify your file output path. Simply click on the folder icon to open the file browser for easy navigation, or left-click the path and type it manually. You will want to make sure to include a file name at the end of this path, but don't include the extension, as that will be provided for you as a checkbox below. Very quickly, I'll go over these checkboxes. Overwrite is a checkbox to specify that if a file name is identical, simply overwrite it without confirmation. This is on by default for a reason, because if you check this off and you start a render after already rendering your scene once, the files generated by the previous render will not be updated, therefore your new render will not be recorded. There are times where you would want this, but most of the time I recommend leaving this checked on. Placeholders is a great way to create the file name before the render finishes. By default, the file itself does not get generated until the render is done with that frame. Cache results will save your render cache, aka your slots, as an open EXR file, which can sometimes speed up compositing calculations in post-processing. This is relatively situational, and default settings for all four of these checkboxes are typically fine. Next, you have your file format. This should be familiar territory if you've ever worked with images or videos before. PNG is a great image file format to use, and your render will output each frame as a separate PNG file on your hard drive. Feel free to use any of the other file format options Blender has available. If you choose a movie file, you'll have an additional section called Encoding that has settings you should tweak. For starters, your actual file extension will be specified by the container value. Also, to make sure you include any existing audio in your render, make sure to select an audio codec from the drop-down menu. Quick and very important tip: even if you're rendering an animation, it is recommended to output image sequences instead of movie files. This is because in case your render fails midway, the files up to that point for your image sequence have already been output, so you can still pick up where your image sequence left off. However, if you are rendering a movie file format, a render that fails halfway will never even become a single file, as it will output a corrupted, incomplete file, leaving you to start over completely from frame 1. Color type lets you choose between black and white, RGB, or RGB plus alpha. RGBA allows your images to include transparency and is usually recommended, especially if you're rendering out passes. Color depth changes the amount of color information in your image. Compression simply affects the file size of your output. Now that we've gotten those settings out of the way, let's quickly show how this works. I'm going to go ahead and animate my cube really quick. I can then render it out by going to the Render menu. Here we have two options, Render Image or Render Animation. If you were to select Render Animation, you would see the output files being automatically generated for you like so. For hotkey users, you can simply press Ctrl F12. Once your rendered animation is done, you can also view your rendered animation by going to the Render menu and selecting View Animation. For hotkey users, you can simply press Ctrl F11. Now, if you were to select Render Image instead of Render Animation, Blender will not output a file for you automatically, as this would actually overwrite a lot of important frames when running single frame test renders. But let me show you how to save a single frame if you need it. Let's go back to the Render menu and select Render Image. For hotkey users, you can simply press F12. From the new Render window, which is simply an image editor popped out, you can go to the Image menu at the top and select Save As. This will allow you to save the image as a new file using the output settings you specified in the Properties editor. If you don't see this new render window, simply go to the Render menu and select View Render. For hotkey users, you can press F11. Sampling is a setting for all three render engines in Blender at the moment, but in this video we'll be specifically talking about sampling in Cycles. You can argue that out of the three render engines, Cycles relies on sampling the most. The higher the samples, the more accurate the light calculations will be. But instead of explaining it, let's just demonstrate this real quick. If we go into our Cycles render engine, we can play around with the sample settings. For the sake of demonstration, let's bring the render samples down to something low. Let's say 10. Now we can render out a test image by going to the render menu and selecting render image. Or you can press F12. If you look very closely, you can see that the image is very grainy and has a bit of noise. Now what I want to do is preserve this render so I can compare it to the new render I'm about to make with some tweaked settings. We can do that by simply changing the slot number. You can change your slot number by selecting a new slot from this drop-down menu here, or pressing J or any number on the number row. I'm going to go ahead and go to slot 2, which will save our previous render in slot 1 as we render a new test. So now we can go ahead and go to our sample settings again and change it to 400. Now if we render it, you'll notice first of all that it will take a lot longer. This is the byproduct of increasing the number of samples. However, the trade-off is that our new render is much smoother. There is very little noise and it looks and feels great. This is the difference between low samples and high samples. However, not every person or project will be able to afford the longer render times for higher samples. So let's say if we absolutely have to render a project with lower samples that has noise, what would that look like? Well, we can simply shorten our playback region to be about 10 frames or so and render out some tests. Let's bring our samples back down to 10 and hit Ctrl F12 to render an animation. As you can see, there is definitely noise in this animation. But there's something interesting about it because it's the same noise in every frame, even when the camera and objects are moving. This can be a bit jarring and very distracting in animations, but there is a value under the advanced options called seed. Seed is basically just another word for randomizer, as it provides random algorithms that can be re-referenced with a seed index. But anyway, this seed is what drives the random pattern of our noise in our render. If you prefer not to have the same pattern of noise in every frame of your render, simply press the clock next to the seed value. Let's try the render again, but with a different file name output to compare the difference. As you can see, the noise is now different for every frame, giving it a more natural look even if it's grainy. Now, this is great, but ideally we still don't want any noise at all, but we still want to have short render times. Believe it or not, this is actually possible with the denoiser. Cycles actually comes with a denoising function that will help remove a lot of the noise left over from lower sample renders. This setting is not actually located in the render settings, but rather in the view layer settings. Simply go there and scroll to the very bottom to check the denoising checkbox. Naturally, there are more settings under the denoising checkbox that you can tweak if necessary, but default settings work pretty great already. Sampling is a very important part of the Cycles workflow, and hopefully this video helps you understand it enough to get started with making your renders even better. In this video, we'll be introducing basic ideas and concepts used in rigging. We will also, however, be going into detail about each step in separate videos. Rigging is a fundamental step for going from static models to animated characters. Without rigging, you would only be able to move and animate objects as a whole. But what is rigging exactly? Well, the broad definition of rigging in CG can be described as the act of assigning relationships between objects so that moving one thing will move another. This can be seen in the very basic example of parenting one cube to another. For example, by assigning a parent-child relationship between these two cubes, you can move the parent cube and the child cube will follow. But you can also create more complex relationships with the help of constraints and armature objects. Constraints are powerful and flexible relationships that can be assigned between two objects, beyond the basic parent-child relationship. With constraints, for example, you can add a copy location constraint to our cube to copy the location of our light object, while also adding another copy location constraint to copy the location of our camera object. This creates a stack of constraints, just like modifiers, so stack order matters. So then you ask, what are armatures? In CG, the word armature is just another word for skeleton. Skeletons, in real life, are made up of bones, which serve as the foundation of how our bodies move and bend. Skeletons in CG are also made up of bones and do the same thing. Allow me to demonstrate real quick. You can download this character from the description down below. So let's say we have a character that looks like this, and you want to start animating it. If you want to move, rotate, or scale the character, only the whole character will move, kind of like a statue. In order to move the character like a character, you would need to, at the very least, be able to bend its joints individually. So let's demonstrate that with the arm real quick. If we simply add an armature and go into edit mode, we will be able to extrude and place our bones within our mesh according to where we might expect bones in real life. This includes the upper arm, the forearm, and the hand, for example. Once we're happy with that, we can go back into object mode and parent our mesh to the armature object with automatic weights. Weights are how you assign certain vertices to certain bones. And as we can see, selecting and transforming the armature will allow us to deform each arm bone individually. Except that it doesn't. That's where we introduce pose mode. Pose mode is the mode where you'll be able to select and transform each individual bone to deform your mesh. These bones can be animated individually and each have their own rotation and location values. Now, in case you feel like the vertices assigned to each bone aren't fully accurate, you might want to adjust the weights. To do this, simply select the mesh and go into weight paint mode. This will allow you to paint your weights, letting you better control how you want the mesh to be deformed. For extra control, you'll be able to add bone constraints to your bones, allowing you to form relationships between bones and objects to make animation easier. For example, having one bone point to another bone to form a simple controller. But what's a controller? Well, a controller is just a bone that doesn't deform the mesh directly, but rather is used to drive other bones in some way. Most of the time, they exist solely to make it easier and more intuitive for the animator to use the rig. We'll go over each of these concepts in separate videos. So I hope this introduces you to the basic concept of rigging, what it is and how it works.
Shut up and sit down.